For chapter 3 now, we have some questions. We have question 2. We have question 2H and question 2B. Integrate the with respect to x of the following expression. So question 2B, you need to integrate. Integrate 4 of 1 minus x. This one similar to integrate of exponential. Okay. To integrate question 2p, you need to integrate 4 1 minus x dx. So this one is equal, similar to exponential, the constant will be same, 4 over 1 minus x, but because we have minus here, I should divide it by minus, and because this is not exponential 4, you need to divide by 4, so learn 4 plus constant because this is an definite integral. This is question 2p. Question 2h, 1 over x e logarithm x. This one substitution, take q log x. Okay, 2h. So 2h is integration for 1 over x e log x. Right? E log x. No. E log x. But I think this one missing the logarithm to which basis. Should be here the logarithm, because if it is ln natural logarithm, so it should be cancelled with each other. Since it is log, we can consider it to base 10, for example. So maybe this question is not so clear. Either you can make it for any logarithm, for example, logarithm 10 or so, or any number, I don't know. So take q, substitution, logarithm x with basis 10, then du is equal to 1 over x multiplied by ln 10. So you can use this substitution. So you have here, this one is equal to 1 over ln 10 integration eu du. And then you can continue finding the result. Okay, also we have chapter 2, we have question 5D. Question 5D. Question 5D. 5D, this one. Okay, by using the given substitution, find the following integral x. Yeah. By using the given substitution, find the following integral 1 from 1 until 1 over 2a dx over a square minus x squared to the power 3 over 2. And x is a sine theta. The substitution is x a sine theta. So go back here again. Question 5D. You need to integrate from from 1 until a over 2 dx over a square minus x squared 3 over 2. 3 over 2. Now our substitution is x is a sine theta. So dx is equal to a integration of sine is cos d theta. So here we have integration d theta a cos theta d theta. A cos theta d theta instead of dx over a square minus x square, which means that a square minus a square sine theta square over 3 over 2. Now a cos theta d theta over a square will be taken as a common factor here. So you have 1 minus sine square theta 3 over 2. 3 over 2. Which is equal. Now here, a square to the power 3 over 2 is a cube. So a over a cube is 1 over a square, can be outside the integration. 1 minus sine square theta is cos square theta. 1. Oh, you couldn't hear me. Is it only you or all of you cannot hear me?
We can hear you.
Oh, so I think Abdurrahman, you have the problem. Okay, so a cos theta over a square, 1 minus sine square theta, this one is cos square theta. So to the power 3 over 2 become cos cube. So we have cos theta d theta over cos cube theta, which means that 1 over a square cos square theta d theta. Now cos square theta, you need to go for identities. You have to go for identities. I think you have to use identities for cos 2 theta, which means that this one will be equal by using identity this one. Cos square theta will be equal to cos 2 theta, 1 over 2 cos 2 theta plus 1 d theta. Usually sine square, cos square, tan square, we go for identities. So here you have 1 over 2 a square. The integration of cos 2 theta is sine 2 theta divided by 2 plus theta. Now you have to, because x from 1 until a over 2, x from 1 until a over 2. So if x equal to 1, either you can change your integration in terms of x, or you can change x in terms of theta. So when x is equal to 1, so sine theta, you can change the boundary. When x equal to 1, then 1 is equal to a sine theta. So you need to find the value of theta. Theta should be equal to sine inverse 1 over a. And if x equal to a over 2, you need to change theta as well. And then substitute. And then substitute. This is the idea for this question. Okay, for chapter 3 also, we have question 16C. We have question, or 10C first. We have 10C and 14A, 10C. Okay. 10. I have a question here. Isn't it a cubed? Which one? Oh, sorry. Here, 1 minus sine square is cos square, right? So it's cos square cube. So cos over, we have 1. Oh, okay. Here we have a mistake. Sorry. This is not cos square. This is 1 over cos square. Should be right. So this is all our incorrect. Should be sorry. This one should be cos. Okay. Yes, we have one student here is correct. So we have easier integration. Okay, cos over cos cube is 1 over cos square, not cos square. Theta, which means that 1 over a square, sec square theta d theta. And the integration of sec square is tan theta. A square tan theta. Which means 1 over a square. Theta is x over theta here is sine inverse x over tan. From 1 until a over 2. Yes, 1 over cos square. Yes, correct. I agree with you, sorry. A over 2. Okay, now go back now for question 10C. Question 10C. Question 10C. This one. This one. E to x, shine to x. E to x, shine to x. How do you think we can solve this one? Question 10C. Integration e to x, shine to x. How we can solve this one? Which method of integration we can use? Do you have any suggestion?
By pi.
By parts. Can. Any other idea? Okay, here, okay, you can use by parts. You can use tabular. Okay, but what about converting shine x to its definition? Because shine to x is equal e to x minus e minus 2x over 2. Can we do like that or cannot? But here, I think that because they ask you to use tabular, you cannot use this one. But you can, for integration, you can use definition. This is an idea. But because I think question 10C, you go back to question 10C, I think they force you to use tabular, right? Here, AX, yes, using tabular method. So you need to go for by parts. You have to go for by parts. Okay, so it's up to you. Okay, you can. But for me, it is easier to integrate using definition. To integrate using definition. Okay, so I will go back. I will keep this for you, this step. So if you can find the integration using this method, then it's okay. Using tabular method, if I need to solve using tabular method, take you choose one for integration, one for integration, one for u and v. So you can take one of integration, one for derivative. Let's try one. E to x, e to x. So the derivative for sine is cosh. Here the integration is e to x over 2. Or the integration for cosh is, the derivative for cosh is sine to x. And here e to x over 4. So you have sine x again, so you can stop positive, negative, positive. So you just multiply and find the answer. So you have here, the integration e to x sine to x will be equal to e to x over 2 sine to x minus e to x over 4 cos to x, no, e to x over 4 cos to x, and plus the integration plus 1 over 4 sine to x e to x plus the integration we can plus the integration e to x sine to x over 4. Then you can move this to another side by minus and continue the solution. But here, if the question didn't ask you to use tabular, it is easier for you to use this one. It's easier for you to use definition. Definition is very easy. But since the question asks you tabular, we have to follow. Okay. We have question 14a. Question 14a. 14a. 6x. This one, partial fraction. This one is partial fraction from 0. Okay. 14a. Question 14a. 14a. We need to integrate from from 0 to 1, from 0 to 1, 6x over x cubed plus 8 dx. Now we need to first make the partial fraction method. 6x over x cubed plus 8 equal to 6x over. Now this one is addition of two cubes. So by using the formula of addition of cube, this one x plus 2, x squared minus 2x plus 4. This one can be so which is equal to 6x. Now you need to use partial fraction. So you have two fraction here. First fraction x plus 2. Second fraction x squared minus 2x plus 4. Now this one x plus 2. This one is linear, so the top is constant a. The second one is a quadratic equation, x squared minus 2x plus 4. But this one cannot be factorized. It has no real solution. So here in the top cannot put constant. You have to put linear equation, which is px plus c. Px plus c. Usually, if we have the highest power here is 2, the highest power here should be 1. If the highest power here is 3, the highest power in above should be 2. Usually, in the denominator is less 1 degree from the denominator. So here we have x squared minus 2x plus 4. So I cannot, here, this is the highest power is 2. So the highest power here should be x, should be 1. So we should have linear equation here, bx plus c. Now we need to solve the equation to find the value a, b, and c. So 6x should be equal a x squared minus 2x plus 4 plus bx plus c x plus 2. X plus 2. So you need to substitute now value of x. Try to find the value, substitute values for x and try to find for a and b. The derivative for sine to x supposed to be cos to x. The derivative for sine cos to x times 2. This one. Then sine to x times 4, right? Like this. The derivative for sine to x is cos to x times 2. The derivative for cos to x is sine to x times 4. So here we need to correct this one. E to x over 2 sine to x minus 2 over 4. We have 2 plus this one becomes not, we don't have over 4, right? Now sine, okay, then 2 cos x, then 2 over 2, 2 over 4. Plus, okay, for question, okay, now for question, this is 14a, but you need to find the value of x. So the idea here that x squared should be bx plus c. The next question is 16C. 16C. This one. E to x over ex minus 1. E to x over ex minus 1 dx. So from 1 until 2. From 1 until 2. Question 16. E to x over ex minus 1 dx. Yes. E to x over ex minus 1. So for this question, we can take u equal ex minus 1. Take u equal ex minus 1, then du will be equal to ex dx. So we have the integration here. Here we have e to x, which means that ex times ex. So we have ex, okay, I will separate it like this, dx over ex minus 1. Now, ex dx, one of them, ex dx, will be du. Will be du. 1 of exu plus 1, this one ex, from here, u plus 1 over u, 16d, not c. 16d was written here, 16c. Okay, I will go for d. Okay, after this I will go for d. Never mind. Over u. So this one will be 1 over 1 over u du. So you can continue the integration. Okay, the question is 16d, not c. Oh, sorry. I choose 16c. Okay, never mind. C is easier. Okay, for c, just take a square minus x square as a substitution. Same. Okay, for 16c, 16c. Your friend asked for 16c. I go back for the word 5. 16d. 16c. This one 16d, right? Okay. This one 16d. And what we need now, 16c. Okay, 16c is same. 16c, we need to integrate from 0 to x square minus x square 5 over 2 dx. So what we need to take is take q equal to a square minus x square. Take q, substitution also, a square minus x square. Then du will be minus 2x dx. So 1 minus 1 over 2 du, a square will be u 5 over 2. Then this is a power function. We can continue to find the integration. We can continue to find the integration. 19D. Also question 19D. Question 19D. 17, 19D. D theta is, okay, this one, T tan X over 2. T tan X over 2. Okay, for question 19, A or B or C or D, you have okay, you have to use the identities because you have cos theta and they ask you to use tan X over 2. They ask you to use tan X over or tan theta over 2. This question will be tan theta over 2. So question 19D, similar for A, B, and C. You need to change your okay, let me solve for D, then similar is all. Okay. 19D. Question 19D. You need to integrate from 0 to pi d theta a square minus 2ab cos theta plus b square. And the substitution you have to use is t tan x over 2. T tan theta over 2. This is substitution you have to use. So dt is sec square theta over 2 multiplied by 1 over 2. Multiplied by 1 over 2 d theta. So in term you have to, because we have here only d theta, so I need to write d theta in terms of dt. So this one 2 dt equal to sec square theta over 2 is 1 plus tan square theta over 2. Which means that 2 dt is equal to 1 plus t square d theta. Or you can write d theta or 2 over 1 plus t square dt is equal d theta. Is equal d theta. Because t is tan theta over 2, dt is 1 over 2 sec square theta over 2 d theta. I don't have here sec square theta over 2. So I have to change this one to t. I have to change it because I need to evaluate d theta in terms of t. So sec 2 dt, sec square theta over 2 is 1 plus tan square theta over 2. And tan theta over 2 is t. So become 1 plus t square. So 2 d theta is 2 over 1 t square dt. So this is d theta. A square, b square have no issue. Cos theta. Cos theta, here you have to use the identity. You have to use the identity. So we have, you can prove from the identities that cos theta is equal 1 minus tan square theta over 2 over 1 plus tan square theta over 2. This one. So will be, so cos theta will be 1 minus t square over 1 plus t square. So you need to change cos theta until t. Cos theta until t by using this identity, this one. So tan square theta over 2 is t square. Tan square theta over 2 is t square again. So you need to change cos theta to this one. So the integration become like that. Your integration. Okay. Instead of d theta, I will write 2 over 1 t square dt. And then a square minus 2ab cos theta a square minus 2ab. Instead of cos theta, I will write 1 plus 1 minus 1 minus t square over 1 plus t square. 1 minus t square over 1 plus t square. Plus b square. Plus b square dt. Which is equal to. Now I will multiply 1 plus t square by all this one. I will multiply 1 plus t square by all this one. So you have we have 2 outside of 2 here. A square plus t square a square. A square times 1 plus t square is a square plus t square a square. Minus 2ab, 1 plus t square will be cancelled with 1 plus t square. So minus 2ab, 1 minus t square. Minus or plus b square times 1 plus t square is b square plus p square t square. P square t square dt. So the integration is 2 dt. Now here a square minus 2ab plus b square, this one, I have a square here, minus 2ab and b square, this is can be written a minus b square. A minus b square give you a square minus 2ab plus b square. Now we have t a square minus 2a b t square plus b square t square. 2 square a square plus 2ab t square plus b square t square. So this one is plus a plus p square t square. A plus p square t square. So now you can, because you have a constant square plus another constant square, you can go for one of, I think, tan inverse, and continue your integration. Because this is a constant and this is a constant times t squared. So you have to go for one of the formula. I think tan inverse. Tan inverse or tan hyperbolic, but I think tan inverse because this one is positive. But you need to check the formula for integrations. The formula for integrations. Then the next question is 22b. 22b. 22, 21, 22b. Okay, 22b, we need to evaluate the integral sine square cos cube theta minus 1. Sine square cos cube theta minus 1. Sine square this question 22p integration of sine square theta sine square theta, then cos cube theta minus 1. Minus 1 d theta. So for this one, you need to distribute sine square first. So this one becomes sine square theta cos cube theta minus sine square theta d theta. Now for sine square integration can be done from the identities. Now for cos cube sine square, I will make it cos cube, I will make it cos square. So here sine square theta same. Now cos cube will be cos theta. Cos square will become 1 minus sine square. Minus sine square theta. So this becomes the integration of sine square theta cos theta minus sine to the power 4 theta cos theta minus sine square theta. So now this can be all solved by substitution method. Take q for the first and second integration. Take q sine theta. Then du will be cos theta d theta. So you have the integration of u square, and cos theta d theta will be du minus u to the power 4 minus integration of sine square theta. This one du. Now for sine square, you have to use the identities. You have to use the identities. The identity for sine square based on the identity of cos 2 theta. So this one u square, maybe this one we can integrate. This one as a power function, u cube over 3 plus u to the power 5 over 5 minus 1 over 2. The integration sine square theta is 1 minus cos 2 theta. 2 theta d theta. And then when you can integrate, 1 is theta and cos 2 theta. Cos 2 theta is u to the power 3 over 3. We can also replace u because u is equal to sine theta. So this is sine cube theta over 3 plus sine to the power theta over 5 minus 1 over 2 theta plus 1 over 2. The integration of cos is sine 2 theta over 2 plus cos plus. So this is the question 22b. We have question 11f. 11f. Okay, for 11f. 11f, integrate with respect to the also partial fraction. Also again partial fraction. Okay, 11f. 11f. So for 11f, you need to integrate 2x. You need to integrate this function 2x squared plus x plus 1 over x squared plus 1 times x plus 1. So you need to write it as a partial fraction. You have x squared plus 1 plus x plus 1. This is a quadratic equation, so here is a linear equation, ax plus b. Here is a linear, so here is a constant. So now you need to solve. Now you need to solve. You need to solve this equation. 2x squared plus x plus 1 should be equal to ax plus b. X plus 1 plus c x squared plus 1. Solve this equation to find a, b, and c. Solve this equation to find a, b, and c. If you have any question for my solutions or what I'm saying, you just can write or you can open the mic. Also for chapter 3, we have question 13. We have question 13. Let me check again, question 13. Find the value of a such that the integration x minus a, x plus 1, 3x plus 1 dx equal to 0. First, you need to integrate first. Then make the what you have is equal to 0. So to integrate here, you need to use partial fraction. To integrate, you have to use partial fraction. Okay, 13. Question 13. Question 13, you need to integrate from 0 to 1 x minus a x plus 1 3x plus 1 dx. First, you need to integrate. Your integration will have a. The answer, final answer will have a. Then make what you get, make equal to 0 to find the value of a. So you need to integrate first. So to integrate here, again, these are both are linear. So x minus a should be, okay, first you have to write down. This one equal to a over x plus 1. This is linear equation, so the numerator should be constant. 3x plus 1 also linear, so here should also a constant. So you need to have x minus a is equal to a 3x plus 1 plus px plus 1. Px plus 1. Now you need to find the value of a and b, but the value of a and b will be in terms of a. For example, take x minus 1. Take x is equal to minus 1. So you have take x equal to minus 1. So you have minus 1 minus a equal to, when x is minus 1 here, so you have minus 3 plus 1, which is minus 2a. And the second one is cancelled, so a is equal to 1 over 2 plus a over 2 plus a over 2. Same for b. B will be a constant. B here will be a constant, depends on a. Then you need to find the integration and make the integration equal to 0. So if you make x here equal to minus 1 over 3, then minus 1 over 3 minus a equal to, this one will be cancelled. This one will be 0, because minus 1 over 3 is minus 1 plus 1 is 0. So here minus 1 over 3 plus 1 shows me 2 over 3p. 2 over 3p. So p is minus 1 minus a over 2. Minus a 3a. So minus a 3a over minus a 3a over 2. So when you substitute, a is 1 over 2a plus 2. The integration here is ln x plus 1. Here the integration p ln 3x plus 1 divided by 3. The result make it equal to 0 because you have equation only including a. Make the result equal to 0 to find the value of a. This is the idea of question 13. We have also question 30, 31. We have the question 30 and 31. Go back for 30 and 31. 30 and 31, 19, 29, 22, 24, 30. Electric current I of a circuit is given by this integration where t represents time. If I equal to 0, if I is equal to 0, when t equal to 0, express the electrical current in terms of t. Okay, first you need to integrate. First of all, you need to integrate, because this is the function that we have. So you need to integrate 60 plus 1 over 40 square plus 9. So let's go back for word 3. Question 30. Question 30. You have I, or the function I, is equal to the integration 6t plus 1 over 40 square plus 9 dt. First, you need to integrate. So here you can use substitution method. Take u equal 40 square plus 9. Then du is 8t dt. 8t dt. So here, but before going for substitution, I have to separate this integration. This integration is equal to the integration 6t 40 square plus 9 plus integration 1 over 40 square plus 9. This one make it t. I will separate so I can integrate. So the first integration using substitution method. T dt is du over 8. So you have 6 over 8, 1 over u du. Plus this one dt is 2t squared plus 3 squared. Right. So here 6 over 8 ln u plus this one, I think tan inverse, if I'm not mistaken. It should be equal to tan inverse. Let me check if it is tan inverse or not. Yes, it is tan inverse. So a here is equal to 3. A here is equal to 3. So this is 1 over 3 tan inverse 2t over 3 divided by 2 outside, because t is multiplied by 2, plus constant because this is indefinite integral. So here ln u is 40 square plus 9. So you have 6 over 8 ln 40 square plus 9 plus 1 over 6 tan inverse 2t over 3 plus constant. Now go back for our question. If I go back for our question, because to find the constant c, because the question if I equal to 0 when t equal to 0, so we need to express the electrical current in terms of V. So you need to find the constant C here. T equal I is 0 when t, because this is I. This is I. Now when t equal to 0, I is 0, which means that 0 is equal to. Substitute this function t equal to 0. So you have 6 over 8 ln 9. 6 over 8 ln 9 plus 1 tan inverse, when t equal to 0, tan inverse 0 is 0. So this one will be cancelled, so you have a plus c only. You have a plus c. So the constant here is minus 6 over 8 ln 9. So you need to substitute here to find I. So I will be equal. This is the value of constant. 6 over 8 ln 4t squared plus 9 plus 1 over 6 tan inverse plus the constant. So 6 over 8 ln 4t squared plus 9 plus 1 over x plus 1 over 6 tan inverse. Two t over 3 plus constant, our constant here 6 over 8 ln 9. This is the current when t equal to 0. This is the value of I when t equal to 0. This is question 13. Okay, now question 31. Question 31. Question 31. In any cycle, the velocity of robotic detector is given by this function, feet per second, where t is time in second. Find the expression of displacement s in terms of t if s equals 0, t equal to 0. Okay, question 31. Question 31. Question 31. Question 31. First, this is the value of the function here is velocity. In physics, velocity is the derivative for displacement. Usually in physics, velocity is equal ds over dt. So to find s, you have to integrate v dt. You have to integrate v dt to find the displacement. No, the application is not included in this too. The application is not included, but the integration is included. So we can just show the integration, how we can integrate. That's all. Okay, so what we need to see here, how we can integrate this function. And I think it is not difficult to integrate this one because 2t is a power function, is okay. 12 over 2 plus t squared, this is tan inverse. This one is tan inverse. So this is easy to integrate. So just only this is to show the integration how, but we in the test 2 there's no application like velocity or displacement and so on. Okay, for question, I think the last question for this chapter is question 35. The last question asking in this chapter is question 35, 36, 35 and 36 actually. Okay, let's check 35 and 36. 34, 35. 35, if ex sine x equal to the derivative, find the value and hence evaluate. 36, find the value. Okay. 35 and 36, same idea. So we can choose one. We can choose 35, 36, same idea. Because same idea exactly. So we can, because after 35, I will go for the second chapter. Okay, because chapter 3, or maybe we can stop here, 35 and 36. It's not so important. Maybe I can send the solution to you on WhatsApp for all of you. Because I have to go for the second chapter. It will take long time for this one. Let's go now for second chapter for 35, 36. because it is not so difficult. I will solve it and send it to you in WhatsApp after the class. Okay, for the second chapter, question 10. You have question 10, 11, 12, 14, 15, and 5D. Okay, let me open the tutorial first. Got this file I will save for chapter 1 so that I can send it to you after the class. I will send also the solution to you so you can follow. Okay, now for chapter 4, this one. Okay, we have for chapter 4, we have question 5D. Question 5D. 5D. 3, 4. 5D x squared. Okay, this one. Question. Is it okay if we continue until 10 today? Make it 2 hours so that I can cover the 5th chapter as well. Okay, that's it. Okay, 5D. Okay, thank you. Okay, for 5D. 5D, you have to integrate x squared over. You have to integrate, this is improper integral from 1 to infinity, x to the power 5 over 1, x to the power 2, sorry, x to the power 2. X to the power 2, 1 plus x squared dx. So here you can use by parts. To integrate, use by parts. But because we have improper integrals, you have to use limit. So this is limit when t goes to infinity. 1 until t. Replace infinity by t and take the limit. X 5c. Okay, because we have 5d here. I will go for 5c, never mind. I will go for 5c, don't worry. But because, no, what I see in WhatsApp is 5d. But it's okay, I will solve 5c as well, never mind. I will solve something, okay? Okay, for 5d, x squared over 1 plus x squared dx. So for this one, I think we can use by parts. By parts, I think. To integrate, you can use by parts. Take q equal x. Take dv equal x over 1 plus x squared dx. So now here, this one by substitution, take t equal to 1 plus x squared, then dt equal to x dx. 2x dx. So v will be equal to v will be equal to integration of 1 over 2 dt over t square over t square, right? T square and x dx 1 over 2 dt. So 1 over 2 t to the power minus 2 become minus 1. So minus 1 over 2t minus 1 over 2t. Okay, now du, which is equal to minus 1 over 2, 1 plus x squared. Now du is dx. So the integration, this integration for x squared 1 plus x squared squared dx is equal to vu, which means that x over minus 2 1 plus x squared from 0 to t, because the integration from 0 until t. And then minus integration, which become plus integration from 0 to t v du, which is 1 over 2 minus 1 over 2 minus 1 over 2 1 plus x squared dx and square dx. Then you can continue, which means t minus 2 1 plus t squared minus 0 plus minus 1 over 2 minus 1 over 2, this one tan inverse x from 0 until t. From 0 until t. Now when you take the limit, you need to substitute t and evaluate the, sorry, from 1. So the integration is from 1. This one is 1. So this one should be 1. This one should be 1. Here the integration should be 1. This one should be 1. Also this one should be 1. 1 over 2. So when we have 1, so here we have 1 t over minus 2 1 over plus t squared minus 1 over 2 plus 1 over 4. 1 plus 1 is 2 plus 1 over 4. We have 1 over 4. Okay, now just substitute t and then take the limit. You have to evaluate the limit then to get the answer. 1 t minus 2 1 plus t squared plus 1 over 4 minus 1 over 2 tan inverse t minus plus 1 over 2 tan inverse 1. So tan inverse 1 is pi over 4 Right. Here, when you take the limit, you have infinity over infinity for this part. So you need to apply L'Hopital rule here. So usually this will go to 0. This term will go to 0. And here tan inverse infinity is pi over 2. When you take limit, when t goes to infinity, first part will go to 0. Because we have infinity over infinity, you need to apply L'Hopital rule, which is 1 plus, which is 2. And this will go to 0, plus 1 over 4 minus 1 over 2. Tan inverse infinity is pi over 2. Tan inverse infinity is pi over 2 plus 1 over 2. Tan inverse 1 is pi over 4. Is pi over 4. Okay, for 5c, because your friend asked for 5c. 5c, you need to integrate using partial fraction. You need to integrate using partial fraction. You need to integrate using partial fraction. 5c, integration of x plus 1 over x cubed, sorry, x minus 1 over x cubed plus 1 dx. So you need to make, because this one is equal to x minus 1 over, this is addition of 2 cubes, so x plus 1, x squared minus x plus 1. So you need to make a over x plus 1 plus x squared minus x plus 1. This one cannot be have no real solution, so it cannot be factorized. So we become bx plus c. bx plus c. Then you need to solve to find the value of a, b, and c. We just now solve one similar in chapter 4. In chapter 3. Just now we solve one similar in chapter 3. And now we have all of you, I think, all the sections. Okay, before going from 10 to 15, 6 and 7 also are asked by students. 6 and 7. 6. 6 and 7. 6 and 7, similar idea. Similar idea. Okay. For 6, we have the integration. Six A or B? The student who asking for 6. Is it 6A or 6B? Or both? Because 6, we have that integration from 0 to infinity. So, e minus x squared dx. This is one is equal to square root of y over 2. This is the error function. Okay, we need to evaluate, for example, a, because b is quite similar. You need to use this integration. He already gave you this integration and ask you to use it to find the integration of e minus x square root of x dx. So just take u equal to square root of x. Take u square root, then du is 1 over square root of x. 1 over 2. 1 over 2 square root of x. So that's all. So you will have 2 du. So this integration 2 du e minus u squared. Then use the one it is given to you. Similar for part B. For part B here, take u ax. Take your substitution u equal to ax. For question 7, take u equals square root of x. So take u equals square root of x. So 6 and 7 is okay. Now because student asked from 10, all of your sections ask from 10 until 15. The questions from 10 until 15 with all have same idea. Okay, let's start from 10. Show that from 1 to infinity, square root of x dx, x plus 1 square. This one exactly what we saw just now in question 5D. Question 5D. Similar to this one. Okay, we need square root of x is equal to t squared. We need to take x equal to t squared. So you will have the same integration. X okay. Question 10. Take x, you need to integrate from 1 to infinity. Square root of x plus 1 square dx. By using the substitution that x is equal t squared. X is equal to t squared. X is t squared. Then dx is 2t dt. 2d dt, which means that 2x is 2t dt. So you have the integration. First, this is the limit when t goes to infinity, because this is improper, 1 over t square root of x plus 1 square dx. So the integration now become, instead of x, I will write 2, because dx is 2t dt. So x is 2t dt. Square root of x is t, because x is t squared, so the square root of x is t. X plus 1 square, x plus 1 square, which means that t square plus 1 square. So this is be the integration 2t square over 1 plus t square dt. This integration by parts we just solve in question 4. In chapter 3, just now we solve the same integration. Chapter. No, this is the same integration. Now here in this chapter 5D. 5D that we solved just now is the same integration. This is the same integration in question 5D that we solved just now. That we solved just now. Okay, for question 11. Question 11. Prove that by substituting x equal a square, a cos squared plus p squared. This one, because it's quite long, I will also send it to the solution by WhatsApp. But it is easy, not so difficult. I mean, it is easy, just calculation is quite long. So I will go for question 12. Given in, the question I told you that I will send by WhatsApp, I will send just after the class. Okay, the integration in is equal to integration from 0 to infinity xn, where n prove that in is equal to in plus 1. Question 12, 13, 14, all same idea. All same idea. Okay, for if I choose question 12 to solve, if I choose question 12, Then we have in. Question 12. The integration n is equal from 0 to infinity x to the power n e minus x dx. You need to prove that in is equal to n integration n minus 1. So you need to go for by parts. You need to go for by parts. Take q equal to xn, then du is nx n minus 1. Take dv is equal to e minus x dx, then v minus e minus x, e minus x. So in, the integration in, is equal to uv, which is x n minus e minus x, minus plus the integration from 0 to t, n as a constant, x n minus 1 e minus x dx, e minus x dx. Okay, make it, because I didn't take the limit yet. That's okay. Make this an infinite. Now, this one, in, is equal to x n e minus x from 0 to infinity plus n integration in minus 1. In minus 1. Now, this part, you have to replace infinity by t and take the limit. You have to replace infinity by t and replace the limit. Now, limit when t goes to infinity for xn minus e minus x from 0 to t will become limit when t goes to infinity, t to the power n minus e minus t minus 0. When you substitute x by 0, it becomes 0. So this is infinity over infinity, but after calculating the derivative many times, this one will go to constant at finally. And will go to constant. So constant over infinity, this limit should go to 0. This one should go to 0. So in, since this one will go to 0, so in is equal to in minus 1. Is it x to the power n? X to the power n, e to the power minus x. Okay, 4 by parts. 4 by parts here. X to the power n for derivative, e minus x for integration, e minus x for integration. So when I integrate this, when I derivative this one, find the derivative. So n x to the power n minus 1, u times v, or u divided by v, u times u times v. Yes, this one 2 times. This is this one here. This one minus e minus x, like this, right? So here this one become positive x. Positive so positive x, positive t. So substituting will give you infinity over e to the power infinity is infinity. So infinity over infinity, you have to apply L'Hopital rule. Have to apply L'Hopital rule. L'Hopital rule, this one will keep e is t when you derive many times, but this one will goes finally to constant. It goes finally to constant. So it becomes, so this will limit should be goes to 0. So in should be equal to in minus 1. This is the integration. This is question 12. 13 same, but you need to take, for 13, take x to the power n for integration. Question 13 same, but you have to take for integration by parts also, but take for x to the power n for integration, not for derivative. Take x to the power n for integration, e minus x squared for derivative, because you cannot find the integration for e minus x squared. So just, but the solution is same. Solution is same. For question 13, you have to take q equal to e minus x squared dv x to the power n dx. And then find du, which is minus 2x e minus x squared. V is n, x n plus 1. X plus 1. X plus 1. And then it is, you can continue. But by same way, the first part limit should go to 0. The first part limit should go to 0. But what I need to highlight here in question 13, because in question 13 they ask you after that to prove it is like that. Okay, in question 13 here, after you prove that in is equal to 2n plus 1 in plus 2, write in of terms of in minus 2. So you need to write in minus 2 is equal to n plus 1 in. Here you need just to replace n by n plus 2. Then n plus 2 plus 2 will become n. This is the relation between in and in plus 2. To find I5, you will use I3. You will use I3, so you will integrate x cubed e minus x squared. E minus x squared. So this is the, you need to use tabular. You need to use tabular. For question 14, same. You need to take same exactly like question 13. Take q x to the power n for integration. For integration, e minus x squared for derivative. For derivative. So same. Same exactly. Okay, 15. X2n plus 1. You can solve 15 also for you. Because from 10 until 15, all same idea. No difference between them. No difference between them. Do you prefer to solve 15 or to move for chapter 5? Do you like to solve chapter 5? Okay, so question 15 also I will send it the solution to you. So we have to go for chapter 5 now. So I will write the solution on the same file. Then I will send to you all the file with the solution and so on. Okay. Let me save the file first. Okay, I already saved. Let's go for chapter 5. We need to open the tutorial for chapter 5, this one. Okay, for chapter 5, the questions for chapter 5. Chapter 5, we have 2C, 2D, 2C and 2D for chapter 5. 2C. 1 over 1 times 2 times 3 plus 1 over 2 times 3 times 4 over 1 over 3 times 4 times 5. Okay, 2C. Go for 2C. Chapter 5. This is we need to use the partial fraction method. We have 1 over 2 times 3 times 1 times 2 times 3 plus 1 over 2 times 3 times 4 plus 1 over 3 times 4 times 5 plus. So here you need to write the nth term. So the first one, 1, 2, 3, this is arithmetic sequence. This one is arithmetic sequence. So this one is 1 over n plus 1, n plus 2. This is the nth step. You need to use the arithmetic sequence. First one is the arithmetic sequence. 2, 3, 4 also arithmetic sequence. The first term is 2, so you have 2n plus 1. The 3, 4, 5 is arithmetic sequence. The third term is n plus 2. Then you need to write this one. A to the power n, p to the power n plus 1, c to the power n plus 2. N plus 2. Then you have to find the value of A, the value of P, the value of C. The value of A, the value of P, the value of C. Right. So the value of A should be 1 equal. We need to solve 1 equal to A, n plus 1, n plus 2, plus P, n plus 2, plus C, n plus 2. So take n equal to 0. So 1 is equal to A, which A is equal to 1 over 2. Take n equal to minus 1. Sorry, this one. Take n equal to minus 1. So two terms will be cancelled. So you have 1 over minus p, which means that p is minus 1. Minus 1 plus 2 is okay. Then take n is minus 2. So 1 will be equal to minus 2 plus 1 is minus 1 minus 2 c. So c is 1 over 2. C is 1 over 2. So the series that you have are these series. 1 over 2 over n, and the value of p is minus 1, so you have minus 1 over n plus 1 plus 1 over 2 and plus 2. Then you need to write the terms of each series. The terms of each series. 1 over 2, 1 over n is, or maybe this 1 over 2n. So 1 over 2 plus 1 over 4 plus 1 over 6. Okay. 1 over 6. R equal to 1, 1 over 2, 1 over 4, 1 over 6, until you have 1 over 2n minus 1, 1 over 2n, 1 over 2n. Then we need to go for 1 over and plus 1. Or first make it the one that we will add together. 1 over 2. I will make this one first. One over 2 and r plus 1. R plus 2, sorry. R plus 2. I will make the positive term first, then the negative term. So here when r equal to 1, so this is 1 over 6, 1 over 8. Continue until we have 1 over 2 n minus 1, 1 over 2n, 1 over 2n plus 1 plus 1 over 2n plus 2. These are the positive terms. So if we add these together, the last one, the last series, r plus 1 and 1 over r plus 1. Right. R plus 1. So this will give you 1 over 2 plus 1 over 3 plus 1 over 4 until you have 1 over n plus 1, 1 over n, 1 over n plus 1. Okay, now we need to add and subtract. 2 minus 2 will be cancelled. 1 over 2 will be cancelled with 1 over 2. This one will be cancelled with minus this one, because here the last one we will subtract. So will be cancelled with this one. You have 1 over 4 will be cancelled with 1 over 4 here. So we have to cancel this one. Now 1 over 6 plus 1 over 6 . 1 over 6 plus 1 over 6 is equal to 1 over 3. 1 over 3. So minus 1 over 3 also will be cancelled. Here also this one will be cancelled. And will be cancelled. Okay, and then 1/8 with 1/8 is 1/4. 1/4, this 1/4 is already cancelled with this one, so we have another 1/4. So we have 1/4. Then 1/10 with 1/10 is 1/5, will be cancelled with 1/5 here. So all the other terms will be cancelled. 1/2 and minus 1, 1/2 and minus 1 will be cancelled with this term. Also 1/2, 1/2n here, and 1/2n will be cancelled with 1/n here. Here all the terms are cancelled. So here we have 1/2n plus 1 and 1 minus 1/2n plus 1. So minus 1/2 or plus 1 or minus plus 1/2n plus 2. This is the result. So same idea for 2D. Same idea for 2D. Same idea for 2D. 2C, 2D. Okay. Question 9. Question 9. Question 9. If x is small, before question 9 we have 5 and 7. I think we have 5 and 7. Before question 9 we have 5C and sorry, we have 5 and 7. Yes, we have 5 and 7. 5 show that for small a, here you just need to, okay, for question 5, question 5, what you need to do is to prove that 1 plus x, you need to find ln 1 plus 2x. Okay, find the Maclaurin series for this term. And the proof it is equal to 2x plus, sorry, 2x plus 2/3x cubed. That's all. Just find the Maclaurin series for this function. So to find the Maclaurin series for this function, you need to find the Maclaurin series for ln 1 plus x first. This is what we need to prove. So just find the Maclaurin series for ln 1 plus x or ln plus 2x. You can start from the beginning by 1 plus 2x. It's up to you. Maclaurin series you need to find at f0. After you find Maclaurin series, you can multiply by 1 plus x to show that it is equal to 2x plus 2/3x cubed. This is the idea for question 5. Same for question 7. Find the Maclaurin. When the question asks you for x is small, it means Maclaurin series, because Maclaurin series we take x around 0. Our point is 0, so means that x is very small. So just find the Maclaurin series instead of tell you. But in the test we usually ask you directly find the Maclaurin series. We didn't give you that x is small, x is bigger. We just ask you to find the maclaurin series. So for question 7, same for question 5, same for question 9, find the maclaurin series. Also for question 7, you need to find the maclaurin series for ln 1 plus x squared over 1 minus x squared, which means that you need to find ln 1 plus x squared first minus ln 1 minus x squared. Minus ln. So you need to find the maclaurin series for ln 1 plus x squared and the maclaurin series for ln 1 minus x squared, subtract to find the result. It should be equal to x squared plus 2 over 3x to the power 6. Same for question 9. Find the maclaurin series. Find the maclaurin series. It should be equal to this number. But I think question 9, maybe you need to, okay, for question 9, find this maclaurin series. Question 9. For question 9, either you find the maclaurin series for e to x minus 1 over 2x plus 1. Find the maclaurin series for this function. This is one solution. It should be equal to x plus x cubed over 3 and so on. This is one way. Or you can do like that. You can prove another solution for the question. You can prove that x plus 1 over 3x cubed e to x plus 1. Find the maclaurin series here and prove it is equal to the maclaurin series for e to x plus 1. E to x minus 1. Proof it is equal to the maclaurin series for e to x minus 1. So you need to find maclaurin series. What you need to do is to find maclaurin series. To find maclaurin series. For question 17. Question 17. Okay, for question 17, the function is x. Y is cos x to the power x. So here to differentiate, take ln. Ln y is x ln cos x. This is to prove that dy over dx is equal to that one. So the differentiation 1 over y dy dx, a product function, so ln cos x plus x 1 over cos x times the derivative for cos, which is sine minus sine. So minus x tan x. So dy dx is y ln cos x minus x tan x. Now you have y and you have dy over dx. So you can get f0 when y is 0, when y is for the function itself. Here. We need to substitute here that y is 0. We need to substitute here. So when x 0, cos 0 is 1, ln 1 is 0. So this is 1 becomes 0. Ln y is 0, which means that y is 1. Y is 1. F0 is equal to 1. F derivative for 0. F derivative for 0, you need to substitute here x equal to 0. So ln cos 0 is 1. So ln 1 is 0. Tan 0 is 0 is also 0. So the first derivative is 0. Now using this first derivative, you need to find the second derivative. Because this is dy dx, you need to find the second derivative. Dy dx squared is equal to, here y is multiplied by this function. You have multiplication of two functions. The derivative of y is y, so dy dx multiplied by this bracket plus y. The derivative for ln cos x is tan x or minus tan x minus x tan x is minus tan x again, and minus x sec squared x. And then find the second derivative at 0. You need to find Maclaurin series up to x cube. We need to find Maclaurin series up to x cube. Then the result, just take x equal to 1 over 4 to find cos 1 over 4 to the power 1 over 4. Cos 1 over 4 to the power 1 over 4. So you need to substitute for 6. For the second derivative, this one will go to 0. The first one is also 0. The first derivative is 0. So this is one also will go to 0. This one also will go to 0. So you need, I think you have x cube. After you find third derivative, you will have x and x cube. You will have a function x cube, because but x first derivative should not be 0. Should be something wrong here. The first derivative, because cos 0 is 1, ln 1 is 0, tan 0 is also 0. So this one should be 0. This one should be 0. Okay, so you have to so you need to find the third derivative. Third derivative should be exact, I think. Okay, this is the question 17. 9, 5, 7, 17. Okay, what about the third section? 2D 24C. Go back again. Okay, for 24C, I will give you the idea here. You need to separate for 24C, because this is the last question I will solve today. Okay, so 24C. Limit when x goes to 0. Now you have sine x over 3x cubed cos x minus tan x over 3x cubed over cos x. I will separate. So now this one, sine x over cos x will be tan x. So you have limit when x goes to 0, tan x over 3x cubed minus tan x over 3x 3x cubed over cos x. Cos x, so take tan x over 3x cubed. Okay. 1 now tan x over cos x, 1 over cos is sec x, because I take tan outside, those will become sec x. So what will you do here? You will find the Maclaurin series for tan x and sec x, and you will substitute tan x, then divide the Maclaurin series for tan x by 3x squared, and also find the Maclaurin series for 1 minus sec x. Find the Maclaurin series for 1 minus 6x. Then you will have the result. Then you will have the result of limit. Okay, doctor, we have a question here, because question 9, chapter 5, right? Question 9. What's the issue? Question 9. Sure. Question 9. Okay, question 9, e to x. Do you, okay, because do you prove e to x minus 1 over e to x plus 1 as a function, or you, I mean, okay, this one. Do you prove this as you take this your function, or you prove by using this one? Okay, if you use by using this 3 1 should be equal, and then find the Maclaurin series. I mean, find the Maclaurin series for e to x plus 1 multiplied by x plus 1 over 3x cubed. And also find the Maclaurin series for e to x minus 1. The first two terms should be stem. The first two terms should be terms, which means 2x plus 2x squared. The first two terms will be same. But the term over 3 will not be same. Okay, the second method, this one. So when you use the second method, you will get, okay, you will get, I will give you the two Maclaurin series, okay? The first one, wait, okay? For e to x, for e to x minus 1, first two terms should be same, but the others will not be same. The other, for e to x minus 1, it will be 2x. It should be like that. 2x plus 2x squared plus 4 over 3x cubed. And so on. But the second one, when you multiply x plus 1 over 3x cubed, e to x plus 1, first two terms same, a 2x plus 2x squared, but then you have 8 over 3x cubed, not 4. But the first two terms will be same. Should be like that. So try to find, so you will have this like this one. So I will stop here. The questions that I promise you to send by WhatsApp, I will send. If you still have a question, you can write in WhatsApp. I will try to solve and submit to all. So continue writing WhatsApp your question. I will do my best to solve the question. Since nobody asked on divergence and convergence of series, so hopefully it's clear for you how to check if the series is converge or diverge. Okay, for divergent test, take the limit. If limit 0 test inclusive or fail. If test not 0, which means that diverge. For integral, be sure that the function decreasing positive and continuous. Ratio test you can apply. For ratio test, take the absolute value of the result. Take the modulus of the result if you have a negative, because we decide after we take the modulus of the absolute value. If less than 1, converge, greater than 1, diverge, equal to 1, test, fail. Equal to 1, test, fail. So if you have any question, can use 13b. 13b. 13b for this one. You need to be sure first, is it decreasing or not? Is it, if not decreasing, you cannot use. If not decreasing, you cannot use. You have to go. I think one of the lecture note example, we solved it by using integral test, but I think it was increasing. I think we have mistake there. But never mind. This one can, if it is not decreasing, you cannot use integral test. Integral test should be for decreasing function. Decreasing function. Here you can use divergence test to take the limit. Take the limit. Here the limit should be 1. Should be 1, not 0, diverge. Try to use the limit. The divergence test is working here. Ratio test, for example, 14a. 14a is ratio test. Usually ratio test, if you have a power like this one, 4 to the power r, this is ratio test. Or you have factorial. For example, if you have like this one, for example, like this series, 2 to the power n over n factorial, for example. Factorial and power directly go for ratio test, because the ratio test will cancel the factorial for you. When you evaluate 2n plus 1 over n plus 1 factorial multiplied by n factorial 2 to the power n. Limit when n goes to infinity. Sorry. Absolutely. Then here. So this will be limit when n goes to infinity as 2 n to n plus 1 n factorial. Because n plus 1 factorial is the multiplication of numbers from n plus 1 until 1. So when you multiply n plus 1 until 1, be n plus 1 times n minus 1 until times 1, which means n plus 1 times n factorial. Times n factorial over 2 to the power n. So this will cancel with this. This one will be cancelled with this one. So 2 over infinity, which is 0. Less than 1, which means converge. So usually, if you have power, if you have factorial, go for ratio test. Usually go for ratio test. Sometimes also divergence is working, but integral test, be careful. You have to check first that it is decreasing. It is decreasing, positive, continuous. Okay. Any more questions? For 2D also, I will send you the 2D in chapter 5. I will send you the solution also. This one, 357, 579, 5. It is similar for the C. Similar for C. But here we go for odd numbers, but same idea. Same idea. Okay. Any other question? I will send this recording for you. I will send the solutions also for you. And the question I promised you to solve, I will send the solution to you or by WhatsApp. Okay? So if you don't have any more questions, let me end the recording.